Hello, everybody. Good morning and good afternoon. Thank you for joining our webinar, and we are ready to start. Today we will tell you about capabilities of the new version of START-PROF, smart and comprehensive pipe and stress analysis software. START-PROF has been actively developing during past years to meet customers' requirements and needs. The new software version supports all actual frequently required codes and standards. It has extended integration capabilities, new modeling features, and some other important improvements that can help to make your daily work smooth and simple. During the webinar, we will announce our online course on pipe and stress analysis. We will also have some polls that will help us to better understand your business and your needs for our further product development. And we hope all attendees will participate in the polls. Whenever you have your questions, please type them in the Q&A box, and we will answer them after the presentation during the Q&A session. I hope that the information provided during the webinar will be useful for you. And now I would like to invite Dr. Alex Matveyev, the head of START-PROF product development team, who will tell you about the new software features in details. Alex, please.
Hello, everybody. Thank you for joining us. I hope you hear me well. So we have a lot of registrations from more than 300 cities around the world from all continents of our planet. So let's start. This is the webinar agenda. We'll talk about the new codes for pipe stress analysis. So it was incorporated into START-PROF software for wind, snow, ice, and seismic loads. Also, we will talk about calculation of stress intensification and flexibility factors for bands, tees, and other elements using the finite element method. Also, we'll talk about the vessel nozzle stiffness and stress calculation using finite element method, trunnion stress analysis using Kellogg method and finite element method, automatic Microsoft Word report generator using the templates, pipe and modeling along with steel structures, pipe support spacing calculation according to the ASME codes, the wall thickness calculation against pressure, advanced expansion joint modeling with thermal friction and pressure stiffening effect, pipe and model import from Microsoft Excel, new databases of flanges, gaskets, valves, beams, sections, new stress ISO generator, and seismic wave propagation analysis. So let me tell you about the pipe stress analysis software, START-PROF, and PAS Suite integrated solution. The first software is pipe stress analysis software, START-PROF. Next software is PAS nozzle FEM software that allows you to calculate the nozzle flexibilities, nozzle loads, calculate stresses and nozzles, and also calculate non-standard components of piping components, stress intensification factors, flexibility, and so on, using finite element method with shell elements. It allows to calculate the stress intensification and flexibility factors for tees, including lateral tees, the piping components with DT ratio greater than 100, bands, trunnions, and so on. And also it allows to calculate the nozzle stiffness, allowable loads, and stresses. It is integrated with START-PROF software, and it is two-way integration, and PAS nozzle FEM just works in the background, and you work only in START-PROF software. And when needed, START-PROF call PAS nozzle FEM to calculate required data, and it is calculated in the background. And another software is PAS Hydro System that allows to analyze fluid flow. And it can calculate slug flow loads. Also, it can calculate the loads caused by the water hammer and transfer them automatically into START-PROF software for pipe stress analysis. And next software is PAS Equip. It allows to analyze different type of equipment like columns, pressure vessels, heat exchangers, tanks. Here you can see the codes, what is included in the past START-PROF software. It is, for example, ASME code, v4.86 code, European code for above ground piping, buried piping, and some other codes, including thermoplastic piping. Here you can see the codes for equipment analysis. It is codes for tanks, for heaters, air coolers, also compressors, turbines, pumps, and so on. Also, we have databases with latest standards for pipes, teeth, reducers, flanges, gaskets, and valves and other piping components that is required to build the model and perform stress analysis, flange leakage check, and so on. And also here you can see the codes to calculate the wind loads, snow loads, ice and seismic loads. Also, we developed the complete pipe stress analysis course. It is hosted by udemy.com. The duration is 35 hours. The price is $30. And we offer the discount coupon for attenders of this webinar. Also, the 30-day trial license is provided for all attenders of this course for free. Also, you can check the feedback on this course on Udemy website, and most of the feedback is positive. Okay, so the next we will talk about the new codes that we added into START-PROF software. We added the blast load calculation using the DNB code, the seismic load codes from different countries. Also, we updated the v4.86 codes to the latest versions. It is v4.1 2022. It's v4.1.H.9 and European code. Also, we updated the pressure temperature ratings for flanges to the latest edition of B16.5. And we updated the information in START-PROF database for bands, teeth, reducers, and for pipes to the latest code editions, and updated the wind, snow, and ice load codes to the latest editions. Totally, past START-PROF supports 35 pipe stress analysis codes. Also, we translated the user interface into Spanish language and improved the import and export capability to Caesar2 software. Now it is much smarter. It allows to read the files created by IsoTracer. It can read the load cases and convert that load cases into START-PROF operational modes. It can read and convert the structural elements, steel structures, from Caesar2 into START-PROF software. Another feature that we added is the special trunnion object, and it allowed to analyze the stress in the trunnion element. We have actually we have two objects. It is trunnion on the band and trunnion on the pipe. The stresses can be analyzed using the Kellogg simplified, Kellogg exact method, or it is most advanced and most modern method is finite element analysis. That is possible to integration to the PAS nozzle FEM software. Let me just demonstrate this. I will open the example file. This is the project, START-PROF project, with several new objects. It is the trunnion object. Let me show. I can delete it. Just click there and add it again here in the T. In the T menu, you can see the trunnion object. You just insert and select which method you want to use to analyze stresses. For example, Kellogg dummy support, Kellogg floor stand, original Kellogg method, or use stress intensification factors. I will choose original Kellogg method. And also here is the band with trunnion object. Here you also can choose which method you want to use to analyze stresses. Okay, And also we have lateral T here. I will tell a little bit later about this. So now, for example, I run analysis. I will not recalculate objects. Okay, so now you can just open the pipe stress table and see here the calculation according to the Kellogg method. For example, you just put your mouse pointer over any cell in this table. It is primary load stresses, stress ranges, and so on. So you put your mouse and you see all the calculation using the Kellogg method and the final stresses that compare to allowable stress. And the same for the bandwidth trunnion element using Kellogg method. Also, you can create the report, file, export, report into Microsoft Word. I will delete all tables and add only Kellogg analysis table. So I will specify the file name. And now we just wait some seconds and we see the stress analysis report. And here you can find the calculation of the trunnion elements using the Kellogg method. You see all the equations, the stress values, allowable stress values, and so on. Okay, using all the load cases in this model. Okay, so next feature is calculation of the trunnions using the stress intensification factors and finite element analysis. How to do this? I'll just open the trunnion element and switch to use stress intensification factors. I can choose this option to refresh SIF and K factors using FEA and click this button. Here you see the values of stress intensification factors. You can enter them manually or you calculate it using the finite element software. How to do this? Just click this button. The pass nozzle FEM automatically calculate, it built the trunnion model, automatically calculated and transfer stress intensification and flexibility factors back to START-PROF. Okay, and the same with another element. It is the trunnion on the band. I will also select refresh SIF automatically, but I will not run analysis right now. I just click OK. And here we see the lateral T element. Also, the stress intensification factors will be refreshed automatically. So now I just click run analysis. We have 3 elements. I will recalculate all objects. And now you see the window with progress bars for 3 objects, trunnion on the band, and lateral T. All 3 objects simultaneously calculated using the finite element method, using all the load cases that we have in past START-PROF software. Okay, so the analysis is finished, and now you can just open the pipe stress analysis table and find the stresses in trunnion element, in bandwidth trunnion, and in the lateral T element, the same way as with standard components. So START-PROF just use the ASME v4.86 code equations and use stress intensification factors that was calculated using pass nozzle FEM software automatically. Okay, it's quite easy. Now, what the integration with pass nozzle FEM software give us? The first is the calculation of stress intensification factors for T-bands, trunnions, and some other elements. The calculation of vessel nozzle and tank nozzle stiffness, allowable loads and stresses. And the important thing is that pass nozzle FEM software is provided for users of pass START-PROF software for free. So if you buy pass START-PROF software, you receive pass nozzle FEM software for free, and integration will work automatically. why we should use the PAS nozzle FEM software for finite element analysis of the non-standard components. For example, the stress intensification and flexibility factor equations in ASME B31 codes and in ASME B31J code has the following limitations. It is applicable only if the DT ratio is lower than 100, and it is applicable only if the branch pipe axis is normal to the run pipe. So it is not applicable for the lateral teeth, for example. And also it is not applicable for trunnions. So if you have, if you run out of that limitations, you can use just finite element method in START-PROF to analyze any piping component that is not covered by ASME B31J. And what about the nozzle elements? Of course, START-PROF has built-in ability to analyze stresses and flexibilities using WRC codes, but it also has the limitations. For example, it has the limitations that you can see here. It is ratio D to D and wall thicknesses and so on. Also, it is applicable only for non-protruding nozzles without reinforcement and only for cylindrical and spherical shell elements. It is not applicable for tangential nozzle like this. It is not applicable for not normal angle vessel to surface nozzle protruding inside the vessel like this. Not applicable for nozzles with reinforcement, and not applicable for nozzles on the conical shell elements, for example, rectangular plate and so on. But finite element method can be used for all of these situations. So let me show you how you can analyze it. I will just open the example model. Here you can see the example model. We have two pump objects here. We have some teeth, bands, and other elements. All elements will be automatically calculated using the finite element method. And also we have two pressure vessels with some nozzles. Here you see the nozzle element. This is the flange element. It allows to check the leakage of this flange. And another element, this one, it is the nozzle element that allows you to check the stresses using finite element method, for example, and nozzle flexibilities. We have several options. It can be rigid, or you can manually provide the flexibilities of this nozzle if you know them. Or you can use WRC code, but it has the limitations. You can use BS code, or you can use the finite element method. And also you can check the stresses, not check stresses, enter the allowable loads manually, use stress check following the WRC code with limitations, or you can check stresses using the finite element method, or you can calculate allowable loads using the finite element method. For example, I will choose allowable loads, and allowable loads will be calculated automatically using the PAS nozzle FEM software for this nozzle. Okay, so you see all the data was refreshed. How to specify the information about this nozzle? You just click this button. The user interface of the PAS nozzle FEM software is opened. And here you can specify the properties of the base element and the nozzle element. The nozzle element is connected to the base element. For example, the base elements can be horizontal vessel, vertical vessel, storage tank like this. It can be T element, different type of conical shells like this. It can be different type of heads like this, including the flat head. It can be elbow, for example, to analyze the trunnion elements, and it can be the rectangular plate. Okay, and different type of nozzles. Let me choose vertical vessel and different type of nozzles. It can be cylindrical, elliptical, and different other configurations. And also in new version, you can insert the structural elements like I-beam, channel, and other different type of reinforcement like this, protruding with reinforcing pads and so on, different type of reinforcing. And also you can define any geometry of the nozzle related to the vessel like this, okay? So you can define the finite element analysis model, and after you finish, you just click return to past START-PROF, and this model will be automatically calculated, and the results will be transferred back to START-PROF. You can do this manually, or it will be done automatically when you run analysis, okay? So, for example, in this model, we have a lot of different objects, the bands, everything is calculated using the finite element method. Let me run analysis of this model. It will take some time, so I will recalculate all objects. This will take some time. As you can see, we have different type of T elements. One moment, it is calculated. It took the resources of my computer, sorry. So you can see here different type of trunnions, welding teeth, elbows, band with trunnion, a lot of objects, and pressure vessel nozzles. And everything is calculated on the fly in several threads using all cores of your processor, okay? So we just need to wait some time to finish this procedure. Okay, while it is calculated, I will continue with presentation. Another feature, it is the PAS hydro system software that allows you to calculate the loads caused by the slug flow and water hammer. I don't have enough time to show this in this presentation because it may take about 1 hour. So you can watch the webinar that we already recorded on our YouTube channel about the calculation of slug flow loads and water hammer loads using the PAS hydro system software. Okay, so let's see how our analysis is finishing. Okay, so it's finished. Now the stress analysis continue. We have a lot of objects that was calculated using finite element method. So everything is recalculated now. We can see the stress intensification factors in all objects that was recalculated using the PAS nozzle FEM software. And of course, you can see the stress table. It's from primary loads, stress ranges, and so on. All the stress intensification factors was calculated using the finite element method. Another feature is the beam elements that allows you to model the steel structures that interact with your piping system. You can define different type of sections. It is the I-beam, channels, and other sections. So let me demonstrate this in START-PROF. Here you can see the steel structure that was modeled in the same model with the piping system. You can see different type of beams. So let me show you how to add the beam element. You can just select any node on the piping system and just click here, add beam element, and then specify the properties of this beam element. For example, you can enter here the length and X direction, select the type of the cross section. For example, I will choose channel. You can define the values of area, moment of inertia, and so on manually, or you can take them from the database. So just click here, select the type of cross section. We have Mexican, American, and other. For example, I will just take some random element, this one, click OK, and you can see the channel I was added to my model. You can rotate this beam element. For example, you can select it and change the angle. For example, you can define 45 degrees. Oh, sorry. You can define it as 90 degrees and so on. So you can build the structural model quite easy, the same as the piping system. Okay. So I will open another model. It is the same model, but the finite element calculation is switched off. It will be analyzed more quickly. Okay, so it is already analyzed. So I will open the deformed shape of this system and show you the animation of the deformations. You see here the thermal expansion of the piping. You can see the thermal expansion of pressure vessels. And also you see that the weight from this pressure vessel transferred to the beam elements of this structural system, of this steel structure, and it deflects under the weight of this pressure vessel. So modeling of the steel structure allows you to take into account the additional flexibility of the steel structures if you perform the static analysis. And if you perform the dynamic analysis, let me show you the modes of vibration. If you perform the dynamic analysis, it allows you to calculate the natural frequencies accurately, taking into account the flexibility of the steel structures. Oh, sorry, I closed it. Let me open again. Okay, so here is the mode of vibration, the third mode, fourth mode. In this mode, you can see that the steel structure also vibrates. So if you will perform dynamic analysis without the steel structure, the natural frequencies and the normal modes will be calculated incorrectly, because it will be totally different when you take into account the steel structure and interaction with the piping system. Here you can see the support, how it vibrates. Let me show. Okay, it's working like this. And also, of course, you should take into account when you perform dynamic analysis, you should take into account the flexibility of pressure vessel, the mass of pressure vessels, this pressure vessel and this. And also you should take into account the flexibility of the pumps. In my training course, I explain how to do this, because all of these influence on the natural frequencies, on results of the model analysis. For example, here are natural frequencies. If you will remove the steel structure, the natural frequencies will be totally different. Here is the line capability. You can hide some lines in this model. You can hide the pipes. You can hide the pressure vessels like this. Okay. So if you'll perform the analysis of the model like this, the natural frequencies will be totally different. It will be incorrect. You should take into account all the surrounding steel structures. Okay. Another feature is the ability to add the internal restraints that allows to connect some pipes with beam elements or with another pipes. Let me show you, for example, here. we have the support, the resting support, where the pipe is lying on these beam elements. So how to model this? We add the rigid elements, and the first rigid element length equal to the diameter of this pipe divided by 2, half diameter, and this rigid element length is half of the beam height. Okay, so if you open the properties of this custom restraint, internal restraint, you'll see here is the resting support in Z direction, and the friction factor is 0.3. You can define gaps, single directional restraints, and so on. Okay, so this is internal supports. Also, the functionality of the internal supports allows you to model, for example, the complex expansion joints like this. This is lateral expansion joint that was modeled using the internal restraints. It works like this. This is the complex model of a lateral expansion joint. You can see here the internal restraints that model the hinge between this rigid element and this tie rod. And another example, it is the pressure balanced expansion joint. It also modeled using the internal restraints. We have 2 vessel nozzles. This is the first vessel nozzle with some displacement. Here you can see the displacements caused by the thermal expansions of this vessel. Here is the second vessel, and the expansion joint between them. The diameter is very high. It is 1 meter. So the goal was to find the correct spring hangers that can hold the weight of this pressure balanced expansion joint. To do this, it was modeled using this complex model like this. And here you see how the pressure balanced expansion joint is working. Okay. So another feature is the export to Microsoft Word. Let me just show this in START-PROF software. I will open the same model. It is already analyzed. The analysis already done. So I will just export the report into Microsoft Word. File, export, Microsoft Word. I will delete all table, add all tables, and also I will add the Kellogg analysis. So here we will see the input data, pipe list, node list, stresses, pressure vessel, detailed report, displacement, internal forces, and so on, MDMT, natural frequencies. So I will just click OK. We will use the same file. I will just replace it. I will have to wait some time while this report is created. Okay, it's almost done. Now this report will be opened using the Microsoft Word, and we will see the result. Okay, this is the report. It is customizable, so you can change the templates of this report. For example, you can replace the logo by logo of your company. You can change the design of this report. It is possible. Here is the contents, the temperature cycles, operational modes, the input data, the detailed information about each pipe element with diameter, wall thickness, pressure, temperature, and other properties in this model, including the beam elements. Another one, it is the material list, the material properties, what was used in this calculation, the node list, the coordinates of each node and its properties, the pipe list, the pipe properties, Also, you can find here the stress table according to the ASME v4.86 pre-code, the primary stresses, expansion stresses, and so on. Okay, MDMT table that allows you to determine if you need to perform the impact check of piping components or not. As you can see here, everything is okay. There is no need to perform the impact check. The equipment loads. Also, you may find support loads, displacements, internal element forces, and equipment loads. Here you can see the detailed WRC nozzle check report. You can see the calculation of the stresses in the nozzle using WRC 537 and WRC 297 booth codes. The next one, it is the analysis report of the pumps using the API 610 code, including the Appendix F of the API 610 code. And also you can find here the trunnion analysis. Let me find it. Yes, here it is. It is trunnion check. So this is detailed report. You can just add some conclusions, maybe some screenshots, and the report is ready to transfer to your client. Okay. Another feature is the pipe list and the node list. We added the ability to import and export the data to the Microsoft Excel using just the clipboard. Let me show you how to do this. For example, I open this model. Here is the node 11, for example, okay? And here is the node list. You can see here the coordinates of each node in your piping model, the properties of this node, the loads of this node, and we have the pipe list with material, line, the projections of this element, some other properties like diameter, wall thickness, mill tolerance, some loads, and many other parameters of each pipe element. And the interesting feature is that you can copy this list into Excel and then backwards. For example, you can select some rows in this table, or you can copy entire table. For example, here you can choose copy entire node list into the clipboard. After that, you open the Excel and paste this table into the Excel. In Excel, for example, I will find the node 11, this node, this one. And for example, I will change its coordinates like this. After that, I will copy this table again. I will just copy it into the clipboard, and then you can select all and just click and push the buttons Ctrl+V, but I will use this feature, paste node list, and just watch on the node 11. I edit, paste node list, and you see that coordinates of the node 11 was changed. So you can modify your model, for example, using the Excel, and then paste back into START-PROF. Also, we added the flange databases, the single flange database, which includes the latest versions of the codes for the flanges, like B16.5.47 and API 6A, European code, and so on. Also, we added the gasket table that includes the information from ASME and European codes and contain required information for the flange leakage check. We added the valve database, beam section database, and some other databases for including the expansion joints. Let me show you. Here you see the databases in past START-PROF. You may see the flange database. It contains the following standards here. and it contains weight, length, and other parameters of each flange. We have single flange database. It is used to model the contour flange for the valves. It contains the weight of the one flange, not the flange pair, but one flange, and contain gasket weight and bolts and nuts weight, and some other parameters required for leakage check using the NC code. And also you may find here the gasket database. Here you may see the codes that is built into the gasket database. It has the internal and outer diameter to calculate the effective diameter of the gasket. Also, we have a valve database with weight and length of the valves, and beam element database for different countries, for different type of cross sections. Okay, so let me show you. For example, I will open some other model. This one, I will open this model, and here I will show you flange element. This is the flange element. For example, if you need to perform the leakage check, you can take the information from the database. For example, I will choose the flange with nominal diameter 500, or you can use MPS class schedule. It can be schedule 10, and choose some type of the flange here. It will automatically take the required information, length and weight, and also you may open the properties of the gasket. You click here, choose the gasket, for example this one, or ring joint, for example this one. So outer and internal diameter of the gasket taken from database, and the gasket effective diameter automatically calculated. And you can perform the leakage check of this flange. And the same with the valve elements. For example, here we have the valve. We can select the standard, select the flange leakage check, take some kind of the valve from the database. The length and weight is taken from the database. So also you may add the flanges, 2 equal flanges. I will just take some random flange, and you can specify the gasket parameters, also take some random value from database, and it is ready to perform the flange leakage check analysis, and you will see the valve with flanges. Okay. Another feature, it is the added the axle coupling object. We added the expansion cushion flexibility for the district heating networks. Our users asked for this, so we add 3 types of expansion cushion. It's soft, normal, and hard. In previous version, it was always hard, but now you can choose which type of expansion cushion you're using for buried piping. Next one, it is the feature that allows you to calculate the span between the pipe supports using different codes, including the ASME B31 code. It uses 2 criteria. The first criteria is stress condition, and the second criteria is deflection. Of course, it uses the conditions individual for each code that you will use. Okay. So let me demonstrate this. I will just open the file with start elements. We will use ASME B31.3. And here you see different type of calculations. It is pipe wall thickness calculation, the band wall thickness calculation. It was available in the previous version, but now we add the pipe span length calculation. You can define the diameter, wall thickness, some other parameters, and START-PROF calculate. If you push this button, it calculates you the recommended span length, the maximum required, the maximum allowable span, and it calculated for operation state and for test state, and for each one it calculates in using the strength condition and stiffness condition. It is allowable deflection. For example, we have this span length. If I will change the allowable deflection, the span length will become greater. So you can choose here the allowable deflection. And for each code, it is individual. For example, you can choose ASME v4.11, v4.14H, any other code, and START-PROF will calculate you the span length according to that code. Also, it is available the wall thickness calculation for pipes and wall thickness calculation for the bands. Why it is important? Because in START-PROF you should enter the wall thickness of the bands. By default, it is taken from the connected pipes, but it is incorrect because bands can have greater wall thickness than connected pipe wall thickness. So it will affect the flexibility of this band. And if you will not enter the correct wall thickness of the band, the flexibility will be incorrect, and the support loads, for example, stresses and some other results will be incorrect. So we need to define the correct value of the wall thickness of the T elements and band elements. So this option allows you to calculate the real band wall thickness, and also now we can calculate the wall thickness for T elements, the header wall thickness. You define the pressure and receive the wall thickness. For example, I will double the pressure and you will see the different value of this T wall thickness. In the last year, we added additional functionality. We have a lot of features. I just show some of them. Also, we added the import from Autodesk Civil 3D software. You can import the model from this software. Also, we added export of support loads into the file for the steel structure modeling software. We added export into the LICAT by Lisega. And in the LICAT version 11, added the function to import the spring properties from the START-PROF software. And here you see the diagram of the import and export capabilities of START-PROF. It can interact with almost all piping design, piping modeling software that you can see here. Some of them supported using the PCF file. With some of them, we have direct integration, for example, Autodesk Revit, for example, Aviva, Everything 3D, PDMS, Civil 3D. The direct interaction, direct import and export features are much more advanced than using PCF file, because PCF file doesn't contain a lot of important information, but direct integration allows to transfer that information into START-PROF. It's much more advanced. And also we have integration with LICAT, PAS Nozzle FM, PAS Hydro System, and Autodesk AutoCAD, Microsoft Excel, AutoPipe, Caesar tool. And the most interesting feature is ability to write your own programs using the C# language or Visual Basic Net, or even the Visual Basic for applications that is built in the Microsoft Excel to create your own application. It will automatically invoke the START-PROF, create some model in START-PROF, perform analysis, and then give you some results. And everything you can do this using any programming language and interact using the API interface of START-PROF software. And some of the converters, some import and export features of START-PROF was created using this API interface. Another feature is the improvement in modeling of expansion joints. For example, To the angle expansion joint, we added the ability to choose one of the two types. It's gimbal or hinged expansion joint, like this. Also, we added ability to consider the effect of the temperature on the bellows stiffness and the allowable rotation range. For example, if you increase the temperature, the elastic modulus became lower for the bellows material, and the stiffness of this bellows became lower. So, for example, if you have several load cases in START-PROF, it's called operational modes. If you have several operational modes with different pressures, different temperatures, for each operational mode, START-PROF will use individual value of the stiffness, of the bellows stiffness. Another feature is the pressure stiffening effect and friction effect in the hinge in the rotation expansion joint. For example, maybe some of you know that the pressure, if you increase the pressure, the stiffness of the band increasing and flexibility became lower for the band elements. And the same happening with the bellows. When you increase the pressure, the stiffness of the bellows became greater. So if you have several load cases, each load case have its own pressure, then START-PROF will use individual value of the bellows stiffness for each load case. And also the friction in this hinge is also important, because sometimes with friction, especially if the pressure is very high, this friction in this hinge can be also very high, and it can be even greater than allowable loads on the nozzle. So this friction affects the loads on nozzles. So it is important to consider this friction effect in the bellows. And also we can consider the length and the mass of the bellows. So sometimes expansion joints are very heavy, especially for the pipes with great diameter, and we should take into account the length and the mass of such expansion joints. For example, when we calculate the natural frequencies and also in the static analysis. Here is the example how the temperature affect the elastic modulus, and of course it also affects the stiffness of expansion bellows. It is the example from Witzenman Hydro manual. You see the correction factor to the stiffness of the expansion bellows depending on temperature. And START-PROF will take the individual value of this correction factor for each load case. So the stiffness will change in different load cases. And also in different load cases, you can have different pressure values and different load cycles. So it also affects the allowable movements, allowable rotation of expansion bellows. It also can be considered in START-PROF for each load case. And the friction and pressure stiffening effect also has influence on the results. So START-PROF also take into account. Here is the example from Witzenman Hydro manual, where you can see the factors that is used to take into account this effect. Here is little bit theory behind this. The more detailed information you can find in my training course on udemy.com. And here the main idea is that you should take the stiffness value of this expansion bellows using the basic value, and pressure multiplied by additional factor that consider the pressure stiffening effect, and additional factor that consider friction. Here you see this factor, the pressure and the rotation angle, but rotation angle depends on analysis results. So we should perform analysis, get the angle, then apply it here, change the stiffness of this expansion joint, then perform analysis again. So we need to perform several iterations. START-PROF do all the iterations automatically. Usually it is required about 3 to 5 iterations to achieve the convergency. And START-PROF automatically do this for each load case. So if you have several load cases, START-PROF will calculate the bellows stiffness, and it will be different for each load case, depending on pressure, rotation angle, and of course temperature. Okay, all this is done automatically. And the same idea we use for lateral expansion joint. Here you can choose the type of expansion joints, for example, lateral with 3 or more tie bars, with 2 tie bars, or any other type of lateral expansion joint. Here you can see the types, and you can find more detailed information in my training course. And also it can take into account the pressure stiffening, the temperature influence on the stiffness, and so on. And also we improve the axial expansion joints. Sometimes you need to take into account the rotation and lateral movements of the axial expansion joints, but usually manufacturers don't provide this information. So how should we do this? You can just enable this option, and START-PROF will automatically calculate the bending stiffness, the lateral stiffness for these expansion bellows. And also after the analysis, it will check the allowable deformations using this equation. It will calculate the effective axial deformations, which is equal to the axial deformations and some equivalent axial deformations caused by the rotation and lateral movements. And all of these should be lower than allowable axial deformation. So let me show you the simple example. I will just show you the rotation expansion joint, but this is applicable for all types of expansion joint. This is just a simple model with rotation expansion joint, and here you see the bending stiffness, the stiffness temperature factor, and we have 3 operational modes here with different temperatures. For example, if I will open the properties of this pipe, I can click here. We have different pressures, 3 operational modes with 3 pressures, and 3 temperatures, different temperature for each operational mode. And also here you see different values of this stiffness temperature factor for each load case. And the same with the allowable rotation correction factor. It also can be different for each load case. Also, you can define the weight of this expansion bellows, and START-PROF will take it into account. The length of this expansion joint, the type. For example, this is the hinged expansion joint, but you can choose the gimbal for like this. You can define the plane for the rods. It can be vertical, horizontal, or any other. And here you should define the properties that is required to take into account the pressure stiffening and friction effect. And all that properties can be taken from the database. You just click here, choose some database. It can be Witzenman, Bellman on some hour. For example, I will choose Bellman. And here you can I will choose some random expansion joint, and all the information was taken from the database to this expansion bellows. Okay, you can add your own information, your own bellows into this database. And also we have some other expansion joints like angular torsion expansion joint, like this. It works like flange, allows rotation. We have ball joints with modeling friction that depends also on the pressure value. You can model different type of axial expansion joints, including the slip joint like this with friction. So the capabilities of START-PROF is very powerful. It can analyze almost everything. So now, and also it is very easy to input the data. The next feature is the import from Microsoft Excel. We have several templates. The first template is for 3D piping, and it looks like this. The second template is mostly for pipelines, including the buried pipelines. You create some Excel table with properties of each pipe, bend radius, restraints, soil properties, and soil movements. So you can model, for example, the landslide effect, the soil drop, or seismic fault model, and any other features for buried pipelines, and just import it into START-PROF. The next template is used when you have just coordinates of the nodes along the pipeline. So you can create the table like this with X, Y, and Z coordinates of each node, and then just import it into START-PROF. And the next template is used to import data from AutoCAD. Using AutoCAD, you can extract data from AutoCAD into the Excel file, and then you can open this Excel file in START-PROF. Let me demonstrate this. I will just show you several templates. For example, the first template, it's start nodes. I will open it. It looks like this. Here is the node coordinates, bend radius, restraints, restraint movements. For example, if you want to model the ship piping, when the ship desk deforms, you can define that deformations here in the restraint movements, the soil properties, soil movements for modeling of the landslide, soil drop, and so on. And you can just drag and drop this Excel file into START-PROF. And here you should choose the template name, choose the units and diameter of the pipe, and after import, you will see the piping model with restraints, already with restraints, with restraint movements. Let me show you here. You see the restraint movement. In this restraint at 0, but maybe in some other it is not 0, I don't remember. Okay, here, I don't remember in which one it is not 0. Okay, so also we have the soil properties. This is buried piping, and so on. Okay, all the model was imported from Excel. Another template, it's node coordinates, just X, Y, and Z. You can create this simple file, and then just drag and drop it into START-PROF, choose nodes coordinates, choose units, it will be millimeters, outer diameter, and click open. START-PROF, import the data from this Excel file and create this model. Of course, after import, you should select all and change something. For example, you can change the diameter of this pipe, you can change the pressure, temperature, and so on, add supports or maybe soil. So you should improve this model after import from Excel. And the last one, it is AutoCAD. Let me show you the AutoCAD model. It looks like this model. It was already saved into the Excel file, this one. If you want to see more detailed, you can see my you can watch my training course on Udemy. I describe this in detail. So now you select the AutoCAD extracted data, click open, and you will see the same model in START-PROF. Okay. So the import and export capabilities of START-PROF is very interesting. Okay, another feature that they added for the last year, it is the stress ISO 3D. It is a new feature that allows you to export the stress isometrics in 3D solid model into AutoCAD. Each element like pipe, bend, T is exported as the object with some attributes, and you can add the dimensions, the dimension lines automatically, or it can be done manually. Also, the tagging can be done. Also, the tables stress from the START-PROF can be created automatically. It's, for example, stress tables and some other tables with stress analysis results automatically created, and you can add it here. And the scale of this model is 1:1, so you will see the model in the real scale, not like in Isogen. You will see the real scale of this model. And also you can customize or export attributes of the layer properties and so on. Okay, so this is a very powerful feature. Another thing is the seismic wave propagation analysis for buried pipelines. You can analyze the buried pipelines for the seismic wave propagation effect. We consider the P waves, longitudinal waves, lateral S waves, relay waves, and Levé waves. Each type of wave creates some deformations of the soil and deformations of the pipe that is buried in the soil. Here you see all the equations. And START-PROF has two methods to analysis of the buried pipelines. It is simplified method. It follows the ASCE 2001 American Wetlands Alliance Code. You can define the properties, the seismic properties of the soil, peak ground velocity, and some other properties. And it will allow you to calculate the stresses, deformations of your pipeline. Usually, this simplified method is applicable for the very long pipelines without any branches, without any significant direction changes. How to do this in details, I explained in my training course, online training course. And also we have the exact method for modeling of seismic waves. It is more applicable for the piping systems and pipelines with branches and with significant direction changes, because every branch of the pipeline or piping system works like anchor in the soil, and this is very dangerous because this anchor will be moved with the soil, so the friction between pipe and the soil, surrounding soil, will not save your piping from the great forces, from the great deformations, because you have the anchor, and the stresses in this branch connection will be very high. So this detailed method allows you to model it more correctly than simplified method. Okay, I don't have enough time to explain all the details, so all the details you can find in my training course that lasts 25 hours with all the detailed information about seismic analysis. So I'm finished my presentation. Thank you very much for coming to our webinar. If you want, you can just read more information about our software in our blog, on our YouTube channel, and in social media. Marina?
Thank you, Alex. Very, very impressive features and capabilities in the new version. Thank you, everybody who has attended our webinar today. So you can see our contact details, and of course, you can see the link to our free trial website page. If you haven't tried our software yet, you should know that you can do it for free. You can download a free, fully functional version, which will be available for you during 30 days. And of course, it will be necessary for you if you would like to enroll for the pipe stress analysis online training that has been created by Alex. And again, you can see the page with the information about this course, and you can see the discount coupon, which will ensure your fixed price of $30 for the course. So I can see that, Alex, you have answered all the questions that we've received today. Thank you for this. But anyway, dear attendees, if you have any questions, please send them to Alex, to PAS team, via social media or to our email address. And here you can see our contacts again. Thank you for joining our webinar. Hope we enjoyed the information provided, and have a good day.